everybody, my name's Anna Tinvenzel. Welcome back to my channel. I am going through this LeetCode problem set, and I'm on LeetCode problem number 44, wildcard matching. So I want to go ahead and jump into this. I did read through the problem a couple times. I have not whiteboarded it out yet, but I don't think I'm going to need to based on my understanding. So let's read through the question, and then I will tell you kind of my approach here. So the question for problem number 44, which by the way is being solved in Python for wildcard matching, is given an input string S and a pattern P, implement wildcard pattern matching with support for question mark and asterisk, where question mark matches any single character and asterisk matches any sequence of characters, including empty sequences. The matching should cover the entire input string, not partial. And then they give you these examples here, and then they give you these constraints. So immediately, right off the bat, I think we should use dynamic programming to implement this wildcard pattern. So we're going to, my approach is going to be a 2D dynamic programming table to keep track of whether the substring, in this case it's going to be S, and P match. So for each cell, which we'll have as dpij, represents whether the first index or I characters of the string S match the first J of the pattern P. So if you can kind of see where I'm headed here, that's where my head is at through all of this. So let's start with doing the length of S and then the length of P, because we need to check those substrings. And then we're gonna start this DP, but before that I want this to be false, and I want to times that by n plus 1. I think that's going to get me, and then I need to do for blank in range m plus 1. Okay, so now we're going to create this base case, which is going to be an empty pattern that can match an empty string. So we're going to start with dp 0, 0, and have that equal to true. Or we don't know how to spell true. And we also apparently don't know how to spell false. So I then want to start a for if loop for j in range, and then I'm going to go for I in range, but for j in range I want to start with asterisks. So let's do j in range 1 n plus 1 if p j minus 1 is equal to asterisk, then dp will be 0 for the first, and then j, which is then equal to dp 0 j minus 1. Okay, so we at this point are iterating through the pattern to for basically for each. So that's what this first part is. So let's go back, because I realize I'm not talking through it as much as I should. So we've initialized the dp size of m plus 1 times n plus 1, where m is the length of the string S, because I realize I need to make this clear. M is the length of this, and n, as in Nancy, is the length of P. So we initialize all of these cells to false here. Then we have, like I said, we set this dp to 0, 0 to true, since the empty pattern matches an empty string. So here this is where we're handling, like I said, the patterns with the asterisk. So we're iterating through the pattern P from the index 1 to n. So if P bracket j minus 1 is set to dpoj or dp0j or dp0j minus 1, that means that it can match to that empty sequence. So then we have to go through and do the same thing for the string s, and then also the pattern p. So for each I from 1 to m, right, and j from 1 to n. So let's say if p j minus 1 is equal to s I minus 1, or pj minus 1 is set then to question mark. So when I break this down into this second loop, I'm hoping this is going to make sense. We're going to say for I in range 1 m plus 1. And then we need it for n, for j in range 1 n plus 1. Oops. So if p j minus 1 is equal to s I minus 1, or this is important, or pj minus 1, oops, is equal to this, then we use dpi j, which can also be equal to dp I minus 1 and dp j minus 1. And then if p j minus 1 for this then is equal to asterisk. Yeah, that should make sense. Then we can say dp I and j, oops, is equal to dp I with j minus 1, or the reverse, dp I minus 1 j. And then all we have to do here is then return dp m n, which, if you remember, are the lengths here. So in theory this should totally be fine, but I'm not entirely sure if this is going to work. So let's see. And actually it contains only lowercase, so just want to make sure I didn't miss any like constraints or anything. And like I said, I did read through this a couple times before, so I knew that I wanted this DP approach. And I think I'm decrementing and incrementing these right. So let's run it. Invalid syntax. So I guess I could do... How did I miss that though? Would that be DP? Oh, because I put an extra DP in there. Okay. Okay, though. Okay, so I just want to reiterate over what we just did. So 2D DP approach, where we used that table. We then used n as a length and m as a length to calculate these substrings. So yeah, let's submit it. I think I talked through it enough. You guys can tell me if I did or not. So (74% and 68%). So in memory, I beat 68% of users with Python. Not terrible. And then for runtime, I beat 74% of users with Python. This is my memory and this is my runtime. Definitely could be improved, but overall for doing this in about, I would say about 15 to 17 minutes, it wasn't the worst. And I'm actually sure that there's a faster way to do this, just because I know, like, for me, just DP with a pattern usually just makes sense doing, or matching and patterns and all that stuff. But I definitely think this could have been improved. However, I'm very happy with the submission, so maybe I'll visit this at a later date, maybe I won't. But I can't scroll. Anyway, thank you guys so much for watching. I will leave this solution in my GitHub repo link, which is going to be in the video description down below. You guys are more than welcome to fork and clone, make it better, make it worse. Try something new, have some fun, and I will see you guys in the next video. Thank you guys so much for watching.